Hey everybody, Mr. Bells here. This is your data analysis video review, just kind of talking about all the topics that you need to know. Again, not going to show you everything again right here, but I'm going to tell you all the stuff that you need to be able to know for it. In fact, I'm even going to, this is for 2020, again, crane situation, but if it's 2020, first trimester, you guys can use your notes on all this stuff. So if you didn't watch the video, you won't know that. You don't need to share that with anybody else, but you can if you want. It's up to you. Again, data A, this is the rationals and radicals test review 2020. Here is some of the material you need to know how to do. Okay, so the first thing is if I had something like this, I say x squared equals, say, 16. I want to know all the solutions for this one. We'd know that in order to get rid of a square, we can square root it, and square rooting is the same thing as raising it to its reciprocal. We do it to both sides and we get x equals, and we'd remember that we'd have to do plus or minus 4. Remember that on even powers, we have to look at the positive and the negative solution. If I was solving this one, x squared equals negative 16, and I square rooted both sides, I'd know that x equals no solution because I'm not allowed to square root a negative number. I could cube root a negative number, for instance, like this. I can cube root. Remember, cube root is the same thing as raising it to the 1/3 power, and then I know that x equals negative 2 because negative 2 times negative 2 times negative 2 does equal negative 8. So we have stuff like that. Maybe I give you something like this, 23,268, and I'm taking the 9th root of that and said, hey, use your calculator to evaluate that. You know that you can either do the 9th root on your calculator using your math and the nth root key, or this same thing applies to 23,268 raised to the 1/9, raised to the 1/9. Remembering again that on the older calculators, you got to put that in parentheses. If I gave you a problem like this, 2x plus 5 to the 2/3 equals 46, you'd know that you'd have to isolate this side first. So if there was like a plus 2 over here and maybe a 5 in front, so I'll make that problem a little bit bigger. We'd have to minus 2 first, and get 5 times 2x plus 5 to the 2/3 equals 44. Then divide by 5 and get 2x plus 5 to the 2/3 equals, what is that, about 8.8. And then you'd have to raise both sides to the 3/2, and you get 2x plus 5 equals whatever that is. I'm going to go ahead and do that on my handy dandy calculator right here. It's got a nice little bar on it. So 8.8 raised to the 3 divided by 2. Remember, I don't need it on the newer calculators, need it in parentheses, you would on the older ones. 26.1, then I would subtract 5, enter, and divide by 2, enter, and I get 10.55. X equals 10.55. And be like, hey, what should I do with this? I should store this in X, just like that. Hit enter, and then retype my original problem. 5 parentheses 2, x plus 5, close parentheses, raised to the 2/3, and then plus 2, and then hope. When I hit enter, it says 46, and it does say 46, which means I've now solved it, substituted it back in, and it works. Yay, smiley face. Okay, so you have to be able to do those things. You have to be able to add, subtract, multiply, and divide radicals. I'm going to give you, I don't know, like the first 10 questions or so, they're all mixed up, but the first 10 questions or so are going to be multiple choice, which means the answer is going to be there. So if you can process through some stuff, that should be okay. Okay. So what else do we got? If I have a rational equation like this, y equals 4 over x plus 6 plus 2, you should know, you should be able to look at this thing right now and go, hey, I know that there's a vertical asymptote at negative 6, 1, 2, 3, 4, 5, 6, like that, and then you should know, there we go. You should know that there's a horizontal asymptote at 2, 1, 2, oops, sorry, 1, 2, pretend that it's right there. And then because this is positive, I know that my thing goes here and here. You should be able to then tell me that there's an x-intercept and a y-intercept. So the y-intercept is when x is 0, so let's just plug 0 into there. So I get 4 divided by 6, which is 2/3 or 0.6 repeating, plus 2. So I get 2.6 repeating. That's the y-intercept. And look, hey, that even looks like the y-intercept on my graph. And then the x-intercept is when y is 0, so plug it into there and solve this. 4 over x plus 6 plus 2. Move the 2 over and you get negative 2 equals 4 over x plus 6. And you multiply up and you get negative 2x minus 12 equals 4. And you add the 12 and negative 2x equals, what is it, 16? Divide by that and you get x equals negative 8. So negative 8 comma 0, there's my x-intercept. Hey, and look at that. That even looks like it based on my graph someplace over in that area. So logical ways to be able to get x and y intercepts. You need to know how to be able to do that. Okay, so what else you got on here? We need to be able to simplify things like this. So if I had x squared plus 7x plus 10 over x squared minus 25, and said, please simplify this. Well, we can't simplify this expression until we've found out what it's made up of. So it's x plus 2 and x plus 5. Your factoring has to be good. The bottom, that's a difference of squares, so that's x plus 5 and x minus 5. And then you can see this x plus 5 kills that x plus 5, and the end result is x plus 2 over x minus 5. Knowing that x is not allowed from my original problem to be negative 5 from that set of parentheses, or positive 5 from that set of parentheses, because those would be vertical asymptotes or holes, VAs. That's what vertical asymptote stands for, or holes in the graph. Technically, there would be one at x equals 5. Okay? I'm going to give you questions where I'm going to give you data, like this, x, y, and then values, maybe like 2, 6, 10, 20, and 100, and 40, and 8, and 1.25, and ask you whether or not these are inversely related, directly related, or neither. And you need to be able to go through based on everything that we've talked about in this class and determine which one it is and be able to tell me why. Okay? You have to be able to do this. Let's say I had 3x minus 2 over x plus 6. I'll go ahead and go through that one. And you need to be able to write this one when you have a variable upstairs into the y equals a over x minus h plus k format, like we did just a couple minutes ago on showing what vertical asymptotes and horizontal asymptotes are. And that takes polynomial long division, so you're going to do x plus 6 into 3x minus 2. I'll say how many times does x go into 3x, and you'll say 3, and we'll write that right there. And then we'll multiply the 3 times this, and we get 3x plus 18. 3 times the x is there, 3 times the 6 is there. And then we take this whole thing and we subtract it. 3x minus 3x goes poof. Negative 2 minus 18 is negative 20. And I now know that my equation will be y equals negative 20 over x plus 6 plus 3. This tells me I have a vertical asymptote at negative 6, a horizontal asymptote at positive 3, and because this is a negative, that the graph would go in quadrants 2 and 4 as they curl in there. The 20 makes it so that it's a little further away from my new asymptote axes. Okay? And then final things that you're going to need to be able to do, we're going to give you a inverse or direct variation situation. So I might say something like this: y, let's do this, y varies inversely as x to the 5th power. And as soon as you see that statement, you should write y equals k over x to the 5th. And then I'll say x equals 40 when y equals 10. And you would write 10 equals k over 40 to the 5th power. And you'd find the k. I'm going to ask you to do that because k is pretty flippin' big, but it is whatever it is. So 10 times 40 raised to the 5th. In this potential situation, looks like I got a 1, 0, 2, 4, and then 6 zeros. So 1,024,000,000 is my k. And then I might do something like this. If x equals 80, what does y equal? Which means you would then do this. Y equals 1,024,000,000 over x to the 5th. And you would take that 80 and you would substitute right in there. And so 1 billion divided by 80 raised to the 5th, and your k value, or your y value in this case, y would equal 0.3125. And if I did it the other way around, I would have to, if I gave you a y value and asked you to find for an x, you'd have to end up taking the 5th root of x to the 5th and the 5th root of whatever the other number was to be able to get to it. Okay, so that's those things. Last couple things on it, there's going to be some bonus questions, and the bonus questions, again, this is for this video review is specific to 2020 first trimester, because we do have a lot of interesting things going on. There's going to be questions from sections 7-4 and 7-5, and maybe something out of 7.3. And if you can do those, you can get some extra credit. Okay, I didn't cover those in class. We didn't have time, but all the information is found on the videos. And if you watch them, and honestly, if you watch this one, it could help you. Remember, again, for 2020, it is open notes. Do a good job with them. So again, this is Mr. Bells. This is for data A, rationals and radical units. Make sure that you've watched other videos, make sure that you stayed on top of the stuff. Again, if you've done all the homework in the Big Ideas Math on your own and gotten in the 90-95%, there's no reason you're not going to get an A or a B on this test. It's up to you. You put in the time, you're going to have great results. Remember to ask questions if you got them in here. If you are a remote learner and you want to take this test on Wednesday, again, in the notes it says 1 o'clock. You can come in and take the test on Wednesday. Good deal. We'll talk to you later. Again, kids who are in here already, Tuesday will be for the A through K kids, and Thursday will be for the L through Z kits. Talk to you later, Mr. Bess. Out.